Following on from the previous video, we were trying to find the arc length from A all the way to B. So zooming into this one particular strip here, it will look something like this. And a reminder of the mean value theorem. So at the moment you've got a function f of x here. The average gradient that exists between here and here, the average gradient would be delta y divided by delta x. Now that equals the average gradient. Well, the mean value theorem states that there must be a value of c somewhere between here and here. There must be a value of c. C could be here, or c could be here, but there must exist a value of c somewhere in between these two, where the precise gradient of this equals the average gradient of this. Okay, so looking at this bit here, at the moment what we've got here is the average gradient, and we've done this in the past. The average gradient, well, there must exist a c somewhere in between here. There must exist a c somewhere in between the two, where it equals, where the true gradient equals the average gradient. Okay, there must be a point c somewhere. Now times both sides by delta x, it will give you this delta y, and then you've got this thing here. So this is like a block times, you're multiplying with delta x. So when you look at this, what it's saying is that imagine you are walking along this function and you happen to be right at this point here. Okay, so imagine you're walking along here, and you happen to be right at this point here at the moment. Now, if you want to know, you are currently here. Imagine you're walking along here. You are currently here. If you want to know this height here, if you want to know delta y here, you can just get you can just get the gradient at this. There must exist a c somewhere where if you get this block times the across here, then it will give you the height. It's just like you saying, let's say at the moment you've got a graph of y equals 3x. Okay, so the gradient here is 3. The gradient here is 3. If you are currently here, if you get this length here, whatever this may be, if you times the gradient, then of course you're going to jump all the way up here. If you are here and then you times this delta x here, if you get the gradient and then you times the delta x here, then you're going to get this height here. Now the same is true here. But if you get the gradient and then you times the delta x, then of course you're gonna get the y value here. But this c, just remember that there exists a c somewhere in between these two. There must exist a c somewhere in between these two here. There must exist a c. Well, if you get this value here and then you times delta x, then you're gonna get the height. Bear that in mind. Okay. So we've done this in the past. Look up the mean value theorem if you still don't understand it. So the arc length is approximately the sum of all these straight lines here. Okay, all these straight lines here. So that so in the previous video we got to this stage here. Okay, and then now using the mean value theorem, we don't want this delta delta y here. We don't want this delta y here. So we would use the mean value theorem and replace this with this. Okay, because hang on. So let's just look at one particular strip. This strip here. Okay. So we've just zoomed into one particular strip. The average gradient here is so the average gradient here is delta y divided by delta x, and there must exist a value of c somewhere in between where the true gradient of this function equals the average gradient. That's what this is saying. Now, if you want to know delta y, then then you would times both sides by delta x. That would then give you delta y. So basically, this delta y here equals delta y. So what we've got here is delta y equals f prime of a certain value c somewhere in between the two times delta x. So this is what we're doing. We're just replacing this with this whole thing here. So that then gives us this thing here. Okay, and there must exist a c somewhere in between. There must exist in a c somewhere in between. But the thing is, because we've got so many strips, in this one particular strip, it will be ck. Okay, so there should be a subscript k in here, but I've just left it out so it looks nice and neat. But this strip next to this one here, let's say this strip here, there must be a c somewhere in between, or this c here will be c subscript k plus 1. So there should be a k in here. So when you move down here, there should be a k in here. Okay, and then if you look at this strip here, there must be a c somewhere in between the two, but then this c here will be called ck subscript whatever minus 1. So well, there must be a c somewhere in between. You do need this k here, but I left it out so it looks it's easier to read. Okay, so this from here we can use a mean value theorem and jump to here. Okay, I will continue in the next video.